So, in order to perform calculations to convert between atoms, moles, and grams, there are a few basic things that we need to know. So, 1 mole of any element is equal to 6.02 times 10 to the 23rd atoms of that element. This is Avogadro's number, and it will be really relevant for all of chemistry. And so, also in 1 mole, the amount of grams is different per element, and it's shown by the amount of grams with that little number on that little square in the periodic table. For example, for boron, it's 10.81 grams, as you can see on your periodic tables. So if we're going to try and convert in between them, for example, how many atoms are in 25.43 grams of boron? We start with what we're given, which is 25.43. So there's 25.43 grams of boron, and it's very important that we keep our units and what element we're talking about for later when these get more complicated. And so then we have to match grams to grams if we're going to be going all the way to atoms. So in order to convert to moles, we have to look at the amount of grams that are in that mole, which we see here again are 10.81 grams of boron for each mole of boron. And so in the same fashion, when we have to get to atoms, we have to match mole to mole. So in 1 mole of boron, we have those 6.02 times 10 to the 23rd atoms of boron, which, when multiplied across and divided, some people like to multiply this number times this number and then divide. Some people like to multiply, then divide, then multiply again. Whichever way you go through that, you should come to 1.41617 and etc. times 10 to the 24th. But with sig figs, we see that there are 3 sig figs as the smallest, and so our final answer will be 1.42 times 10 to the 24 atoms of boron. That's our final answer for this. So with a few more practice problems, if we want to see how many grams are in 6.832 moles of sulfur, we can start with, okay, so they're giving us the amount of moles, so that's 6.832 moles of sulfur, and we have to get to grams, so we're only going to need the calculation that converts moles to grams. So we have to match on up and down. 1 mole of sulfur, according to the periodic table, has 32.07 grams of sulfur. And so when the moles cancel out, we're left with grams, which is what we're looking for up here. So we're not going to need to do any extended multiplication on that. And so, So 6.832 times 32.07 is equal to 219.102. But again, with sig figs, we have 4. And so then our final answer will be 219.1 grams of sulfur. How many moles are in 2.39 times 10 to the 4th atoms of calcium? So again, we start with what they're giving us, 2.39 times 10 to the 24, atoms of calcium, which we're aiming for moles, so we're going to need to use the atoms to moles conversion. And again, matching atoms to atoms, we use Avogadro's number of 6.02 times 10 to the 23rd atoms of calcium for every mole of calcium. And then that'll be the end of our conversion because atoms cancel out and we're left with moles. And so those numbers divided out end with 3.970 and so on. But again, with 3 sig figs, we have 3.97 moles of calcium as our final answer for that problem. So our final example, how many grams are in 3.92 times 10 to the 23rd atoms of gallium? So we're starting with atoms, so let's write that down. 3.92 times 10 to the 23rd atoms, gallium. And so then, in order to get to grams, we first have to go through moles. So we're going to have to match atom to atom again. 6.02 times 10 to the 23rd atoms of gallium for every 1 mole of gallium. And so atoms are going to cancel out, but we still are at moles and we need grams. And so then we know, according to our periodic table, that for every mole of gallium, we have 69.72 grams of gallium. And then atoms and atoms cancel out, moles and moles cancel out, and we're left with grams, which is what our question is asking for. And so doing all the arithmetic, we end up with 45.399 and so on. And with sig figs, again, we have 3. We end up with 45.4 grams of gallium. And that is our final answer.